Unit 4, Day 3 notes. Today we're going to be talking about corresponding parts of congruent triangles. Congruent triangles. If two triangles are congruent, then their corresponding parts are also congruent. The converse of this statement would say, if all the corresponding parts of two triangles are congruent, then the triangles are congruent. And if both of those statements are true, then we could write our biconditional statement, which would read, two triangles are congruent if and only if all of their corresponding parts are congruent. And lastly, I'm going to introduce you to CPCTC, which stands for corresponding parts of congruent triangles are congruent. I know my handwriting is horrible, but that's what it stands for. Again, I repeat, corresponding parts of congruent triangles are congruent. CPCTC. Now we're going to talk about the congruence transformations. You should have been introduced to transformations in your past. And there are basically 4 types. Of those 4, there are 3 that will remain congruent. You have reflections. You have translations. And then you have dilations. Not dilations. Sorry, rewind. You have rotations. Those 3 will be congruent. In other words, your shape will not change size or origination. It just flips across a line or slides across or turns a specific way. So triangles will also have congruence properties. The reflexive property would look something like this. If triangle ABC is congruent to triangle ABC, then triangle ABC is congruent to triangle ABC. You'd expect to see the same thing on both sides. Symmetric, however, says if triangle ABC is congruent to triangle XYZ, then triangle XYZ is congruent to triangle ABC. Symmetric, that means to switch. And lastly, transitive, we talked about this a couple times already. You look for a repeat in the middle. So it would look something like this. If triangle ABC is congruent to triangle PET and triangle PET is congruent to triangle XYZ, Then cut out the repeat and simply say triangle ABC is congruent to triangle XYZ. So those are the reflexive, symmetric, and transitive properties from a triangle's perspective. So we were given our first example, triangle ABC is congruent to triangle EFD. So that means all the corresponding parts are the same. The first thing I would do is start with the corresponding angles. That's usually easiest. Corresponding parts will be in the same location when you read the triangle name. For example, angle A is first, so it will match up with angle E, which is also first from the second triangle. So those will be congruent. So angle A is congruent to angle E. Then angle B is congruent to angle F. And lastly, angle C is congruent to angle D. Okay? Now we're going to mention the congruent sides. When you name a side, you must name it using two letters. And again, it's still about the order that it appears in the name of the triangle. So for example, side AB is the first side mentioned. It'll be congruent with side EF. So I want to put a tally mark on that side. That's one tally mark. And use the segment bar above it when you name it. And make sure the lettering is in this correct order. A is with E, B is with F. That does matter, ladies and gentlemen. It does matter. The next side that is congruent, according to the name, would be side BC with side FD. So I will place on that side 2 tallies to show that it's different from AB, but it's the same as DF. So again, BC is congruent with FD. And lastly, you have AC is congruent with ED. So it would get 3 tallies. AC congruent to ED. So 1, 2, 3, 1, 2, 3. All right. Though the original name of these triangles were ABC and EFD, you can rearrange the letters and create a new triangle. As long as you keep them the corresponding letters in the same order, it is a justifiable triangle. For example, I could start with B, so triangle B followed by C followed by A, and then if I changed it like that, that means I would have to start the second one with F followed by D followed by E. So there are several different combinations of triangles that you could create. I'll just name one more just to show you that it doesn't matter, but the order of the letters do. So I could say triangle CAB is congruent to triangle DEF. So again, make sure the correct angles go in the correct locations. All right, let's practice again with this one. We got triangle is congruent to triangle EHT. So the first angle, L, will be congruent with the first angle, E. So L with E. Next, you have angle I congruent with angle H. So it gets two arcs. Also notice how I label the angles in the picture. I wanted to make them the same across triangles, but in one triangle it has to look different than the previous one. So angle I with angle H. So again, if it has the same type of arc or the same number of arcs, the two angles are congruent. Don't forget that fact. And lastly, we have angle Z would get three arcs as well as angle T because those two are congruent. Now let's label our sides. First would be LI together with EH. So I would give it one tally. So segment LI is congruent with segment EH. Next, you would have IZ with HT. IZ and HT. So it would get two tallies. And then lastly, you have LZ with ET. And just for demonstration purposes, I'll only write down one of the other possible triangles. And I could say triangle ZIL is congruent to triangle THE. So on number 3, they give you the triangle and they want you to list the 3 congruent angles and the 3 congruent sides. So I'm pretty sure you can do this one on your own. If it helps, draw a picture, but you shouldn't need to draw a picture. Now for number 4. They tell you that triangle love is congruent with triangle dog, and then they provide us with 3 of the angles. Only 2 of the angles provided are congruent, and those will be the 2 that we'll use to solve for x. So I know that L is congruent with D. I also know that U is congruent with O. And notice I have both U and both O, so those will be the 2 I use. So I know angle U is congruent to angle O. So that means their measures are equal. So now that I know that, I can set up my equation. I would say 9x plus 12 equals 11x minus 2. And now I can solve for x. First, subtract 9x on both sides. Leave me with 12 equals 2x minus 2. Add 2 to both sides will give me 14 equals 2x. So divide by 2, you would have 7 equals x, or x equals 7. Number 5, similar idea, but now we're looking at it from the sides point of view. So again, when you name the side, you must name 2 letters. I have IM congruent with EN, or if you look at it the other way, NE and MI. So I'm given both of those, which is nice. So now all I need to do is set those two equal to each other. So again, MI is congruent to NE, which means that the measures equal. So again, I would write what they gave us. 3x plus 1 equals 8x minus 24. And now solve for x. First, subtract 3x. So that would give me 5x minus 24 on the right. Then add 24, which would give me 25 equals 5x. Divide by 5. So 5 equals x. And now they want us to find the length of NE. So that means we need to substitute back in. NE was 8 times x minus 24. So now we know it's 8 times 5 minus 24. 8 times 5 is 40. 40 minus 24 is 16. And now we have one more example, which is not pre-printed on your notes. Just add it to page 39. Or you could put it on page 38, which is totally fine too. It says other polygons can be congruent as well, not just triangles. So the definition, 2 polygons are congruent if and only if all of their corresponding parts are congruent. Number 6, quadrilateral ABCD is congruent to quadrilateral RTPL. Solve for x and solve for y. So let's solve for x first. I have x located here on side DC and side LR, but are they congruent? No, they are not. However, I do know that LR is congruent to DA. So that helps a whole lot. So that means LR is equal to DA. So that means 3x plus 2 is equal to 20. Now you can finish the problem and solve for x. To find y, you must do something very similar to that. We have PT, which is congruent to BC, or CB. So that's how I'm going to find y. So again, TP is congruent to BC. Gotta make sure I get my lettering in the correct order. So TP equals BC. With that being said, you have 8y minus 2 equal to 22. And that's how you would solve for y. And this concludes your notes for today. Again, finish where I left off on example 6 and make sure you take a picture.